Happy day, YouTube. My name is John, and this is my channel, The Intermancer. Let me show you some interesting things I've been working on. The last episode was a little bit of a side trip while I used Claude to help me learn some things about Python, a language that I'm not intimately familiar with, though I've had some experience with over the years. At this point, the episode before last was a little disappointing because the AI did not give me the code to do what I wanted it to do. And I've been thinking about how to deal with this. So what I am going to do is I am going to use the AI to help me learn how to do this coding myself, and then I am going to have the AI synchronize my context documents based on the code that I have written myself. Again, this whole channel is an experiment for me to learn how to use AI effectively. So I'm going back and forth, learning different techniques, and I recognize that I am not doing things in the standard way, which is very cost heavy. As one uses these command line tools or various coding tools that sends a bunch of things up to the AI and gets a bunch of data back, I am focused more on learning how the AI works and how I can use my own contexts to use the AI effectively. So this is different than what most AI coding channels might provide, where they tell you how to do a thing, and I'm going on pedantic detail on how to do this one thing. I am going to hand code the basic evaluator. I'll use AI to help me learn how to use this streaming technology that is apparently new, because apparently my coding has frozen with Java 7, because that's what a lot of enterprises are frozen on. And now I am learning Java 21, and this whole streams thing that came in on Java 8 is new to me. So I am using AI to learn how to use the more recent coding paradigms. And then what I'm going to do is ask the AI to look at the code I've produced and update my context files. So this is the basic evaluator that was generated by Claude. Now, here I made the decision in this code right here. I believe I was making the decision that all of the training data can live in memory. This is definitely one of those decisions that I will revisit later, especially when my training data becomes an external service, but that is a long way in the future. For now, historical data is just going to be something that gets loaded into memory. So load historical data path. Now, right now I have historical data path as going to training data, historical prices. And the very last episode, something I did was to reverse the historical data. So I actually want to use that reversed data. But what I want to do is make this configurable. So what we're going to do here is we are going to rename this. Where's rename? Rename to default. Okay. And then I am going to say that there is private. Do I need static final Don't need static, don't need final string. Training data path equals set a getter and setter for that real quick. Oh, look at all that. Okay. And now I'm going to update the, I tabbed through all that. I don't know if any of you noticed that, but I just accepted the suggestions. I did read them. I read those suggestions and I decided that is what I wanted, but it is a little anathema to my intentions here to be accepting those suggestions so readily. So I'm going to try to be good about actually reading the suggestions before I accept them. We'll see how well I do on that. Historical prices reversed. Okay. Got the date time, historical data is there. First time through, evaluate, return. Okay. Skip. So it says it wants to skip. Can I get info? I'm new to stream, so let's look at what does the streams.skip method do? Common uses. All right, skip 1. That's what I want. 1. So I could pass in a bunch of lambdas here. I gotta say though, that passing in a lambda will make my evaluate method longer than my screen. And I think it's a problem that a lot of modern developers use convenience methods at the expense of readability. And having everything, the body of a method fit within a screen helps the cognitive processing of the developers that follow to understand what is being said. So rather than creating a lambda inline, I would rather, in most cases, especially in things like this where I am planning on doing a significant amount of processing, I would like to define methods and pass those methods in to the stream arguments. So that's what we're going to try to do. Okay. Map to double. Feed the organism the current data. Get the organism's prediction. Whoa. Consume. So data quantum comes in. Evaluate organism. Stream. historical data. Load historical data. Oh, look, I'm skipping here, so I don't need to skip up there. Okay, since this is, I'm going to say get training data path to URI. Since I'm skipping there and load historical data, I don't need to skip here. Map this parse data row. So if values.length is less than 2, return null. For int I, values.length. Okay, so it trims it up. If I equals 0, convert to epoch time, parse date to epoch. Okay, this does the, if it's less than 20,000, so if it's 2-digit year, it adds the 2000. And date as start of date. Epoch milli, that's a standard, and it returns, that gives us a long, and everything compiles. Parse date, data quantum, add value. Okay, this casts it. So it does the first one as a date. Else, it just does the double dot parse double and adds that value. So for each of the values that comes back in the row, it does that. For the first one, it converts the date to an epoch millis, and then it returns a data quantum. Get data points is empty. Then it returns null, else it returns a data quantum. So it's saying, is the data quantum that it instantiated at the beginning, is it empty? Then just return null, otherwise, okay. So parse date row, data row, that's good. Filter, make sure it's not null, and then collect into a list, and then pass out, return. It does all the streaming and it returns a list of data quantum, load historical data. Okay, so now we're going through that list of data quanta, and for each data quantum element in there, we are going to pass it to the organism, which we will consume. The prediction will be the last one. This is a standard structure. Then what we will do is we will, okay, here's where the whole thing messes up, because what we need to do is we need to keep track of the last few of these. Let's see. Consumption count, lead consumption count. Is that in there? Where's lead consumption count? So, okay, we need a default value. Private static final int default lead consumption count. Wow, 3. Okay, so it's got all that. That's great. And then lead consumption count equals default lead consumption count. That's great. Does it have a getter and setter for lead consumption count? Get. Does it have set? Public void set lead. It was given. Okay. All right, we'll take that. This dot lead. Why is that an error? Okay. Cannot assign to a final. That makes sense. We'll make it not a final. Okay. Next thing we need is we need to keep track of the next however many of these values that we've seen. And so we will do a queue. I believe Q is correct. Java data processing technique. Okay. Tell me about the Java queue API. First in, first out. Poll peak. Does it have a size? Remove. Okay. Resizable array DQ. Linked list is general purpose, good for frequent additions, removals. We're going to be adding one and taking away one every time. So we'll use a linked list. So Q. What are we going to do? Where was I? Right. I was making sure that I was researching on the queue. So Q of double lead data new linked list. Okay, we will go with that. What's the error there? Cannot find symbol Q. Add Java util. What's still wrong here? Okay, so first, the double prediction. So let's see here. The prediction equals that. So lead data add, no, offer prediction. What is the error here? I think it needs a double. That's what it needs. Okay. That's that. So we also need a Boolean lead count met. It's false. If so, okay, I've been thinking about this whole, do I want to compare to a count as I do this loop? I know optimizing on Boolean comparisons is probably a fool's game, but it's the OG developer in me trying to do optimizations wherever I can think of them, even though a lot of them are unnecessary. So I realized a couple of days ago that if I just have a Boolean true false in my loop, then that's more efficient. So I initialize it to false and go through it and check the count. And if the count is at a greater point, then I make lead count met to true. Hopefully that'll make sense here in a minute. So if it's not lead count code met, then if, okay, is there a way to do counts during streams? Is there an implicit count variable when I am processing Java streams? Okay, so we will have a count int lead count equals 0. So if lead count met, if it's not lead count met, then lead count plus plus. If yes, 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 that is exactly what I want. Return 0, skip scoring until we have enough data. Wow, okay. But then the next time through, it will say that actual value. And okay, prediction equals that. So if lead count is not met, then lead count blah blah. And now what I have to do is I have to add, okay, lead data dot offer prediction. So then let's see, double current prediction. What happened to lead count? Met. Okay, this is me learning about lambdas. If bang lead count met. A lot of restrictions on this whole lambda thing. So I think what I want to do is start another variable. If local variables in a lambda expression must be final, how do I update, keep track of state as I process the string? Okay. Mutable container objects. Except I need to keep state because I need to be tracking how many go through. Use stream operations for state. Update sum.update and get. Map to double values. I need to process my stream as a singleton stream. I can't distribute it when I'm evaluating a single organism because I need to process multiple rows of data and keep track of kind of a running average. So custom collector. Here we go. Mutable state can cause issues with parallel streams. At this point, I don't think I can have parallel streams, and I really think that that's part of my problem here. Transform data instead of tracking state, create indexed collections. When you need mutable state, use atomic integer or mutable containers. So atomic integer, atomic reference, what is that? What's atomic reference? Filter map to int. Mutable containers. Okay. Counter dot increment. Counter dot increment. What does that do? Counter. New counter. Increment. So it's just an object that you call operations on. Reduce. All right, I'm wondering if this is a limitation of my own thinking. It might be. But for now, I need to have an for each. Okay, so atomic integer, but I need this thing. Okay, so it looks like I am going to have to, I don't know that I'm going to finish this. In fact, I'm not going to finish this, but what I need to do is I need to have a prediction container. That keeps track of this lead count met and lead count and all of the things because of these issues with a lambda, which means I'll be able to get away from the lambda because I'll be okay. So I was thinking, could I turn this into a method call? And for me to turn this into a method call, I need more complex structures, and it looks like I'm going to need the complex structure anyway. So that's what I'll end up doing. Thank you for your time. Sorry for the mumbling. I have been learning how to use these modern lambdas, and I still have some things to learn. So I'll do some research off camera, and we'll see what we come up with. Again, thank you for your time.